Hey guys, so today's video will be on measurement again. Here we are measuring mass and weight. Okay, mainly this video will be differentiating between mass and weight. I know in English mass and weight have about the same meaning, but here they mean very different things and you cannot confuse the two of them. All right. So first, let's talk about mass. Okay, mass is defined as the amount of matter in the body, right? So the unit is kilograms. Okay, if you see mass in a formula, you'll see the symbol m there. Okay, a small m. Like let's say net force equals to ma. Okay, this represents mass, right? And then all the other things represents things like force lah, and this a is acceleration. Okay, as you see more physics formulas, you'll see that each of the letters usually will represent quite a very specific thing. Okay, okay, okay. So physical objects that you can touch, right? They are obviously made out of atoms and molecules and ions and whatnots, right? So as long as the number of atoms and molecules do not change, the mass remains constant. Okay, most of the time, most of the time, by most of the time, I mean 99% of the time, they do not change. Which basically tells you what? Mass always constant. By what I mean by always constant, the mass, no matter where you are on Earth, you're on Mars, you're in outer space, your number of atoms and molecules will be the same. And therefore, your mass will be exactly the same. Your mass will be exactly the same no matter where you are because the number of atoms and molecules are the same. Okay, stress again, the mass is always constant no matter where you are. Okay, inertia is a property of mass. Okay, inertia is a property of mass. So the more mass you have, the more inertia you have. And what does inertia do? Inertia forces you to remain in motion if you are already in motion, or it forces you to remain at rest if you are already at rest. Okay, so if let's say I got a very big object in outer space, okay, all the way in outer space, a very big object, it will be just as difficult to stop because of inertia. All right. Okay. Next, we go on to weight. Okay. Weight, on the other hand, right, weight is a force. Let me write it out so that you remember. Weight is a force. Okay. What is this force? This force is exerted on an object due to gravity, and of course, only planets have a gravity big enough to be appreciated, right? So when a planet pull an object, the pull is weight. Okay, weight is not due to the object itself. Okay, look at the definition of mass. Mass is due to the amount of things in the object, right? Weight is due to another object, in this case a planet, pulling on my apple, let's say. Okay, so when an object is in a gravity field, okay, my apple feels a force. This force is weight, right? And then the SI unit is in newtons. Okay, so okay, so weight and mass is related with this formula. Okay, W is weight, M is mass, G is acceleration field strength. This number, every planet has a number. So Earth number, right, is 10 Newton per kg. For the moon is about 1.67. let's say for Mars, okay, we have around 4. Okay, so all these numbers, of course, you don't need to memorize. Okay, but just take note that every single planet, all right, it has a different number. And once that number is right, the number will stay with the planet. All right. So no matter how much mass there is, okay, for Earth, the gravitational field strength will always be 10. Okay. And if you take that object to go to the moon, it will always, the G will be 1.67. All right, let's look at an example on how we play around with mass and weight. Okay, so I have a gravitational field strength of Earth, okay, is 10. Okay, this is 10. And this is 1.7. Okay, the object mass on Earth is 5 kg. Okay, what is the weight on Earth? Recall the formula: weight equals to mass times gravitational field strength. Then I got the mass is 5. Is it SI unit? Yes, 5 kg. Kg is SI unit. Good. Then after that, I take 10. And then I end up with 5 times 10, 50 newtons. Right? Part 2. They ask for the mass of the object on the moon. Recall that the mass always remain constant. So this one, no calculations required. Straight away, just write down 5 kg. Okay, mass remains constant. Okay, so mass on the moon, the weight on the moon, same thing. So the weight on the moon is the mass times the gravitational field strength. Okay, now the mass is still 5, but the moon's G value is not 10. The moon's G value is 1.7 only. Okay, so that gives me 8.5 newtons. Okay, so your weight is less on the moon. Your mass is the same. Okay. Okay. So here is a neat table here. Okay, comparing the difference between mass and weight. Okay. So mass, the amount of matter, right, which is a property of the object itself, and weight is actually the amount of force that the planet is pulling the object, right? Okay. All forces are vectors. All right. We will learn about vectors and scalars in another video. Right. Remember the SI unit to be kg versus Newton. Right. And the most importantly, the mass of an object is always constant. Whereas the weight of an object depends on location. It depends on what planet it is and depends on the G of the planet. Okay. All right. So with this video, hope that you are more clear about the difference between mass and weight, okay, and be very clear about what they are. Okay, and that'll be all.